Hi, my name is Lien, and today I'll be talking about the new chemists, such as a machine learning robot searching for new reactions. So, an overview of the machine learning algorithm. What can this machine do? This machine can predict an abundance of different combinations with several possible reagents. Therefore, it can efficiently navigate the chemical reaction space. Also, it is able to exhibit artificial intelligence, thus, it can adapt and self learn the information. For instance, after only knowing 10% of the reactions, it can predict about 90% of the reactions without performing the experiments. To analyze the reaction, the machine consists of an NMR, which is an analytical chemistry technique that demonstrates the content, purity of the sample, and its molecular structure. Infrared spectroscopy is analysis of infrared light interacting with a molecule and is used to identify functional groups in molecules. An LDA, which is used for modeling differences in groups and can be used to explain the relationship between a group and an object, and an SVM. It's a computer algorithm that learns by example and assigns labels to objects. As a result, 4 new reactions were discovered using this robot. As you can see in the figure in the right-hand corner, it displays the machine learning algorithm and all the techniques that it consists of. Some key points to know about this machine are: the machine learning algorithm can teach itself as it progressively searches the chemical reaction space. It can predict the reactivity of approximately 1,000 reaction mixtures with greater than 80% accuracy, and it can perform experiments simultaneously. The machine can perform 6 experiments in parallel, therefore allowing up to 36 experiments per day. This is faster than any chemist can do manually. The chemical space composed of 2 and 3 component reactions formed from the pool of the starting materials, giving a total of 969 possible experiments. So the issue in discovering new reactions manually is that it can be a time-consuming and unpredictable process, especially when trying to figure out the right reaction that produces a sustainable product. Therefore, this robot will be able to benefit chemists because it gives them an advantage in being able to discover these new reactions efficiently, effectively, and accurately. So y'all are probably wondering how this robot works. Well, first, the robot is given a reaction identifier, which is a spectra that consists of several starting materials to explore the chemical reaction space. The machine compares different starting materials by their spectrum and their reactivity to calculate the probability of reactivity for different reaction combinations. It randomly selects and combines the different materials. Therefore, the database is built from scratch and there is no bias, and leading to a valid result. The second step is that it will predict and rank the reactivity of reactions formatted in binary code, which will be sorted out by the supported vector machine, or SVM. As you can see in the right-hand corner, this figure shows how the SVM categorizes the reaction as it classifies them as either a reactive or unreactive reaction. In step 3, the LDA model will construct a representation of the chemical space, and from this model, the probability of the reactivity of the reactions can be predicted. The machine will be able to function without any prior information because it builds up a picture of how the reagents react with one another. Therefore, LDA will be able to choose the desired reactive reactions with the highest potential. In this figure, it displays the cycle the robot undergoes to complete the chemical reaction space. As the process continues, the machine's self-learning capacity increases. The machine avoids many non-reactive reactions, therefore performing a quicker process. It displays a pool of starting materials to the analysis of the starting materials by utilizing the different techniques it consists of, and it goes to the SVM where it is categorized into the reactive or the non-reactive reactions. The database gets updated, and then LDA is updated and utilizes it as the final step. Does this machine work? Yes, it was tested and investigated by the Suzuki Miyahara reaction space. The machine was trained with the neutral network, and when the neutral network was tested, it gave yields with a root mean square of 11% for 1,728 reactions. As a result, the machine can predict the yields of the Suzuki-Maharia reactions. It was then established that when the robot discovers 10% of the reaction, it can predict the rest of the reactions without finishing the trial. Future experiments. Why every chemistry laboratory needs this. Every chemist needs this machine learning algorithm because they can use this machine to discover new reactions. It's convenient for all chemists because they do not have to endure the time consuming and unpredictable progress of reactivity of reactions. It is efficient because it is able to predict and test many possible combinations of starting materials to create a reaction quicker than any scientist performing it manually. And it gives the chemist an extra hand and advantage. Therefore, every chemist will find this robot beneficial in their laboratory. Thank you.